Good afternoon.
Good afternoon.
Welcome you all to another session of the talk series organized by the Electrical and Electronic Engineering Society of Faculty of Engineering, University of Pennsylvania. So the topic for today's session will be Exploratory Data Analysis using Python Pandas. This is an approach or philosophy for data analysis that employs a variety of techniques for you as future engineers will be really helpful in your projects related to data science and machine learning. So from today's session, you will be able to learn about data pre-processing for applications related to machine learning and data science. So without further ado, I would like to give a brief introduction to our guest speaker today, Dr. Nilay Karade. Dr. Nilay Karade has a PhD in machine learning and a master's degree in computer science. He also has more than 12 years of experience in the field of machine learning. So it is a great privilege for us to have him here with us today. And thank you very much, sir, for spending your valuable time in spite of your busy schedule to share your knowledge with us. So to begin with, I would like to invite Mr. Sandalu Andasuriya, the Secretary of the Electrical and Electronic Engineering Society, to address the gathering. Over to you,
Sandalu. Good afternoon to everyone. First of all, I would like to warmly welcome Dr. Nilay Karade, our guest speaker today. As previously mentioned, he is a PhD holder in machine learning and has over 12 years of experience in software development and machine learning. I think he is very well capable of clearing your doubt with regards to this topic and anything related to machine learning. I highly suggest you to take this opportunity and clear all your doubt while in this session using chat box or raising your voice. One final thing, I emailed the dataset which gonna use in practical session. If you haven't downloaded it, I will send it to the chat box here. Please download and make sure upload it to your Google Drive. Thank you very much.
Thank you, Sandaru. Now I would like to cordially invite Dr. Nilay Karade to conduct the session, and I hope all the participants will get the best out of today's opportunity. Over to you, sir.
First of all, Oyata Stuti. Sorry if I have mispronounced Sihali sentence. Okay. Thank you very much.
Thank you.
Thank you all. Thank you very much to the Society of Electrical and Electronics Study Group. Okay. I would also like to thank the teacher, faculty members of the department and university and the official members who have been involved in arranging this session. And also thankful to Sandalu, who is the secretary of this society. And thank you all for joining this session. So I believe that my screen is visible to you and I'm quite audible to all of you, right?
Yes, sir.
Okay, thank you. Just a moment. Oh, it seems that my mouse is not working. Okay, here I have got it. Just a moment. Okay, you have shared the CSV file. Okay, fine. No problem. So now we are going to do a session on exploratory data analysis, right? Fine. So just want to know on the scale of 1 to 10, how comfortable you are with Python programming. Can you just put it in the chat box window? On the scale of 1 to 2, how much comfortable you are with Python? Okay. Now, see, we are going to use a Python programming language. Okay. We are getting some answers here. Let me check. Lakshan is saying 5. Harindo is saying 6. Okay. Fine. Don't worry. So I believe that some of you have a quite good command in Python. Some of you are at the beginner level, right? So that is okay. Don't worry about it, because exploratory data analysis is more about the conceptual thing, right? You can learn the programming syntax at any time, but here the in this particular session our focus will be more on the learning the concepts behind exploratory data analysis. I'm not going to write the code from the beginning. I have already prepared a code for the same, so I will just share that code with you and we will move further. Okay. So what is exploratory data analysis? First of all, let me tell you that it is one of the phase of data science life cycle. So this is a data science life cycle, as you can see on the slide. We start with business understanding, followed by data collection, and then comes EDA, that is exploratory data analysis. So I'm going to we are going to we have this session dedicated for this particular phase of data science life cycle. And what we do in exploratory data analysis, basically real life data is quite messy. As you can see on the slide, we have got legos of different color, different shapes. They all are mixed up, right? So similarly, real life data is quite messy. It is you have to clean it, right? So that it can be fed to a machine learning model, and then you can do some prediction. And in order to clean it, there are various scientific statistical ways, right? There are some data visualization techniques using which you can clean your data, right? So what I decided that instead of directly switching to the EDA, let me just give you a brief introduction of what is data science and machine learning, because you can see in this science life cycle, we are doing EDA, we are doing machine learning modeling and all that, right? So let me just give you a brief introduction to what is data science. Now, instead of telling you the definition, let me start with a real life example. Maybe that will help you to get a better understanding of data science in a nutshell. So, for example, let's say you have a manufacturing plant. Okay, you own a manufacturing plant. You use some raw material, right? This is raw material, and you have also employed some people uh, to work in your manufacturing plant, right? So these two will be the inputs to your manufacturing plant, and you will produce some kind of products at the end of it, right? So using this raw material and these staff members. Now you will arrange some logistic, right? You may arrange some uh, goods carrier vehicle, right? And you will send it to the market so that you can sell it to the retailers or to the dealers, right? And then you will earn some money at the end of it, right? So this is how your business cycle is there, right? Now let's consider a couple of scenarios. For example, in scenario 1, you were following your usual business process, right? This much is the amount of raw material you have procured, this much is the amount of people you have employed, and this is the amount of products that you are producing. Let's consider for a particular month there was a increase in the market demand for your product, but unfortunately, since you were producing only this many number of products, you could not cope up with the uh, demand of the market, right? So in that case, what is happening? You could have earned more money, right? You could have earned more money because there was a huge demand in the market. But unfortunately, since your business line was not ready, right? Your business process was not ready. You didn't have enough raw material, enough staff members to produce that much amount of goods, right? So you end up with having losses, right? Now consider scenario 2, where you have invested a lot in raw material, you have also employed more number of people, and hence you are getting more amount of products produced at the end of this, right? But unfortunately, let's say for that particular month or for that particular quarter, there was not that much demand in the market for your product. So in that case, what will happen? You were expecting a lot of revenue, right? But unfortunately, since there was not that much requirement in the market, you are having losses in your business. So in both the in both the scenarios, you can see that since you are not able to cope up with the market demand, you are not able to, you are not able to have you are not able to maximize your profits. Now, what is the solution for this? Well, here comes the data science into picture. You will hire a company or a data scientist, right, which will do the data analysis, and it will help you to get an idea what are the problem areas, uh, what what needed to be fixed, so that you can maximize your revenue, right? So for example, a data scientist may ask you for your previous sales data. Now this previous sales data may be available in your billing software, right? So you may fetch that a data scientist may fetch the data from the database, right? uh, or or you may do some survey in the market, that what kind of qualities are people are looking for in your product, right? So there are different types of data. Let's say maybe your product are perishable, so you may also need weather data in advance, right? So this kind of data can be fetched from some third parties, right? So there are various types of data. Any relevant data which is related to your business can be fetched from the various sources. Now once the data is collected, what data scientist will do is he or she will apply a data analysis and data cleaning on it. Now what exactly it means? It means that first of all, it will see if there are any discrepancies in the data, if there are any some errors in the data, right? Such as if there are any null values, if there are any missing values, if there are any outliers. So all these are some of the statistical terms. If you don't know them, it's okay. Don't bother about it, because I'm going to explain in the session. So it will use some statistical methods uh, to see how the various variables in your data are related to each other, right? So this is how the data scientist will come up with a solution to maximize your profit. Now once you have analyzed the data and cleaned the data, that data will be fed to a machine learning model, and then that machine learning model will understand the pattern in the data, and it will do the sales prediction for you. Now since you have such kind of a prediction system in your hand, right, now you already know that what is the expected sale in the next month, and accordingly you can procure that much amount of raw material, that much amount of staff you will employ, right? And you can see that now you are making optimum use of your resources, right? And you are earning handsome amount of revenue. So in this way you can see that how data science is helping business organizations or enterprises to make data driven decisions, right? So now let me take you to the formal definition of data science. Data science is nothing but a study of the data, which includes extraction, analyzing, visualizing, and managing of the data, so in order to create some insights out of it. And these insights will help the businesses to make data driven decisions. I hope the concept of data science is clear to all of you. If you have any questions, you may put it in the chat box. Fine. So the concept of data science is now clear. Now let me discuss quickly about what kind of data is involved in data science. One of them is structured data. It is usually arranged in a tabular form. You can see that it consists of some columns and rows, right? Some columns have numeric values, some columns have text values, right? And here we have rows referenced with a particular index. So this is basically a structured data. Now, what is unstructured data? Any data which is not structured in nature is basically unstructured data. So email data, right? The text written in the email or the word file which contains some text, social media comments or likes, server logs, audio, video, images files. So all these are examples of unstructured data. So when you do EDA, there is a different strategy to handle unstructured data and structured data, right? Even in structured data, we have got different types of structured data. I'm going to discuss about them in a while. And let me tell you, okay, now that we have understood what is data science, let me talk about for next couple of minutes about the machine learning, and then we will switch to EDA. I think somebody's mic is unmuted. Okay, in case if you have any questions, please drop me a message in the chat box, or you can unmute yourself and ask me. Okay, fine. That was all about data science. Now, what is machine learning? Before that, I would like to introduce you to the concept of learning. May I know now? I'm asking you a question. What is this symbol? Now you must be wondering what kind of this question is this, right? I mean, it says number two, obviously, right? But how you came to know that this is number two? Because since your childhood, your parents or your teachers might have explained you that whenever you have such kind of a curve followed by a horizontal line, that that particular symbol represents a digit 2, right? And you might have drawn it several times, you might have seen it hundreds of times, right? And this is how you learn the things. And once you learn the things, doesn't matter if that symbol is again shown you in a different, with a different style, with a different size, you will be immediately able to recognize it, right? So you have learned the pattern in this digit 2, right? In that symbol 2, right? And that is how you do the recognition or prediction. So scientists thought of developing same learning capabilities with the machine. So they thought that why not create machine learning capabilities, so that machine learning, so a machine which is nothing but a computer machine uh, will be able to learn the pattern in the data, hidden pattern in the complex data, and it will remember those patterns once it has learned those patterns. And next time whenever you give input, uh, whenever you input a new data, that model will do the accurate prediction. So that is machine learning in nutshell. So here we have, okay, I will just skip this one. Okay, well, this point is quite important from EDA point of view. So whatever things I'm discussing, we are going to use in EDA. That's why I think that it is, so please pay attention. Okay, so here we have a data set of house price. So you can see that we have size of house, number of bedrooms, number of bathrooms, and finally price of the house. So from the data set, you have to first understand which one is your dependent variable and which one is your independent variable. So as you can see here, the price of house depends on all these factors such as size, number of bedrooms, and number of bathrooms, etc. Right? So what machine learning will do, as I have mentioned, it will establish the relationship between the independent variables and dependent variables. It recognizes the pattern in them, right? And it does, and since this is a mathematical model, machine learning model is nothing but a mathematical model. So it sees the numbers and establish relationship between them. For example, let's consider a hypothetical example, that in this case, after looking at the data, after learning the data, it come up with a equation that if we multiply size of house with value v1 and lot size with value v2 and so on, and and then we take a sum of all these products, we will get the house price. So whenever I say that the machine learning model is learning the pattern in the data, basically it is establishing some mathematical equation, okay, and finding out such kind of parameters such as v1 and v2 and v3. So there is a mathematical process computation going behind this machine learning and all that. Okay, now that machine learning model have learned it, learn the pattern, now we can feed a new data to our model, and it will do the prediction, which is nothing but the price of house. So this data is something which was not used in the learning phase, right? So that is all about data science and machine learning. Do you have any questions related to it? I think it is important to, I mean, some of you, most of you must be already aware of these terminologies, but just I want to explain them. I want to again explain them uh, with real life scenarios. Okay, I believe that you don't, since you don't have the questions, let me go ahead. So yeah, so now how a data science project starts. Well, it starts with business and the underlying data understanding, right? You must know the whole business process, as I have explained you in the earlier case, where there was a manufacturing plant and you want to maximize your revenue, right? So you need to know that, okay, uh, they need some raw material, they need some staff members to produce the good, and that has to be cope up with the market demand, right? So that is what I mean by business understanding. You should know the whole business process. What are the various steps involved in it? What are the uh, variables? What are the uh, things that affect the businesses, right? So that understanding has to be gathered first. Once you have that understanding, then you can formulate a problem statement for your data science project. So in earlier case, we have gathered the sales data, survey data, weather data, right? And then we have formulated a statement that problem statement that we want to predict the sales demand, right? And if we could predict the sales demand, then in advance we can gather the appropriate amount of staff, raw material accordingly, right? So this is a problem statement, right? So that is done in the first phase. Second phase is data collection. So as I have shown you, the data maybe can be fetched from your databases, right? Or it may be collected from a survey, right? Or it may be collected from a third party, such as we had seen example of weather data. Now, once the data collection is done, next comes an EDA. So here we will do the data analysis. We will remove the errors from the data. We will clean it, right? And finally, we will feed it to the machine learning model, and that model will do the prediction. In our exam, in case of our example, it was the sales demand figures, right? So that is all about data science, machine learning, and EDA in a nutshell. Now, I would like to switch to the implementation part of EDA. First, before that, I just want all of you, if you have understood the concept completely, hmm, c- can you give me feedback in the chat box? Fine. Now let's switch to the programming part of the EDA, right? For that, we are going to use, okay, thank you, Sandalu. Now we are going to use something called as Google Colab. Now, what is this Google Colab? Google Colab is basically a cloud-based IDE where you can run your Python or data science related code, right? So what I'm going to do is that, I mean, I ask all of you to repeat the same thing at your end. You open your web browser, right? And inside web browser, you search for uh, Google Collab. Okay. Then now you click on this first result, which is collab.research.google.com. Okay, you click on it. Right, and okay, I will use this one. uh, just a moment. I will share one file with you. Please look at the chat box. I'm going to share one file with you. Give me a moment. Yeah. uh, please look at the please have a look at the chat window. I have shared one file with you people, right? Please get it downloaded on your system. I believe that you have downloaded it and it must be located in your downloads folder, right? Now what we are going to do is that uh, I have already shared that CSV file with you people, right? And you will have to upload that CSV file in your Google Drive. I mean, those people who have installed Anaconda, they can go with the Jupyter notebook, right? And those who haven't installed Anaconda, this is a ready-made solution. You don't need to install anything. You don't need to download anything, right? So that's why I'm using this particular thing, right? So I believe that you have downloaded the file which I have just shared, and you might have also uploaded your data set into your Google Drive, right? Now what is the next step? Next step is to, ideally we create a new notebook, right? You have to click on a new notebook, uh, but I have already written the code for this EDA, and I have just shared it with you, right? So and it is currently it is in your download folder, right? So we want to upload that file into this Google Colab, right? So for this, you click on this upload button, right? And then comes this choose file option. Just click on it and redirect yourself to the download folder from where you can upload that EDA on used car dataset file, right? Now why I'm giving you this ready-made code, because see, we have got a limited time, right? We are left with 1 hour, I guess. And EDA is, I mean, it is quite extensive process. I mean, it takes a lot of time to analyze the data, to write the code and debug the code, right? uh, Sometimes you may go back and forward to get the things fixed, right? So it is not possible to cover everything in one session, but to save some time, that is why I have shared that file with you. So I believe that you have clicked on this upload option and then click on choose file option, and from here you can select the file which you might have downloaded, right? In this case it is located here in my case, right? Just click on it and then click on open, right? So that will upload the file, okay, and it will get open here. Where is my file? Just a moment. Recent. Yeah, sure. I will share it again. Just give me a moment. Mm, yeah,
So
here it go.
I shared it.
Okay, okay, no problem, no problem. I've shared it. Okay, so I prefer this dark theme. Okay, by default you may have a light theme, right? So because when you write a code for about 8 to 10 hours on daily basis, right? So this kind of dark theme is it will give you a sort of relaxation to your eyes compared to the light theme, right? So that's why I have used this dark theme. Fine. So you have uploaded the CSV file into the Google Drive, right? In your Google Drive, and you have also uploaded this code file into your Google Colab, correct? Now, how to write code and how to execute it? Well, it's very simple. You can see that there is this run button, correct? And you have to just click on it to execute that particular block of code, right? Or another option is to use a key, that is shift and enter simultaneously, right? You press shift first and then enter. Make sure that shift button is shift key is pressed, okay? Then only it will work. So what I'm doing here, I'm importing some files. And what are these files? Some of them are related to the data manipulation and some of them are related to the data visualization, correct? Now, since we are working in a Collab environment, right? So I will have to read the file, the file which I have shared, right? This file from my Google Drive, right? So for that, I will have to add this extra code over here, which might not be present with your file. So what I'm going to do, I'm just going to copy it, right? All you can do is you click on this first cell, okay, and just move your mouse to the bottom of this cell, and there is option plus code and plus text. So you click on this plus code button, right? You click on it and it will create a new cell below it, a blank cell, right? So I'm just sharing a code in the chart window, right? Please get it copied from the chart window and paste it into your uh, Google Colab notebook. And this has to be done after the first cell, okay? So the moment you execute this code, okay, what will happen? In my case, the drive was already mounted. In your case, it will give you a link, okay? A link will be in a blue color, right? You click on that link and it will open a new web page. It is just and it will ask you to select the Google account, right? Your Google Drive account. So you will have to enter the credentials, and once you enter the credentials, you give access to your Google Drive. It will give you one code, some alphanumeric code. Just copy that code and paste it. I mean, you must be having a link in the first line, followed by there must be a text box where you have to put that code which you have just copied after the uh, after the successful after successfully giving the permission to access your Google Drive, right? Now I'm gonna share another piece of code, right? So here in this code, let's have a look at the slide. Look at my screen. So here what I'm doing is that pd.read csv. What is pd? Pd is nothing but a pandas. It is a library from in Python, built in Python, which is used to manage the data, uh, such as, I mean, you can retrieve the data from various source, right? And once you have retrieved it, you can do some operations on it using pandas functions, right? So here we are reading the CSV file which I have already shared with you, right? And here the path I have mentioned is content /g drive /my drive, then comes the name of the file. So in your case, it is going to be the same path unless you have not uploaded your CSV file into some folder, right? So this is the root directory of your Google Drive. Okay, so from this is where I can read my CSV file. I hope all of you are comfortable with whatever I have explained you up till now. You're getting everything. Maybe some of you were not ready, right? They might not have uploaded the data. That's fine, don't worry about it. Try to focus on the explanation part. Code is already there with you. Sandalu and other teammates can help you after this webinar uh, to get all these things done, right? So I believe that we have set up the data. Okay, actually it is by mistake, right? No need to import it twice. Ashan, I hope you have understood, right? So it was accidentally I have written it 2 times, right? No need of writing it 2 times. Fine. So we have read the data. Now after reading the data, this data is saved in a variable called df. I guess that font are visible to you. Shall I increase the font size? So after reading the data from this CSV file, I'm going to save it in a variable called data frame, df. The name of the variable is df, and the data type of this df is data frame. Okay, so data frame is basically an arrangement where you can store a tabular data, right? So, and after that I'm calling this df.head function, right? So this data frame have one function called head, so I'm just calling it, and let's see what is the output of this. So here is my data set, right? And as the name suggests, it is a data set of car. Now let me tell you what is the source of this data. Now there is a platform called Car Dekho in India, right? And it facilitates uh, to sell your car, used cars. Okay, and you can see here that that there are lots of cars, used cars, which have been uploaded by the owner, and you may go into, I mean, if I click on any one of them, right? So it will give me the details such as the images, then further details about the car, right? I can see uh, the seller's details, etc. And you can see that it is also showing me some information about the car, right? How many number of seats are there, what is the engine power, engine size, mileage, etc., right? So as I was telling you that the very first phase in data science project is to understand the business. So we have got a fair idea about about this particular business, right? Now what kind of solution we, data science and machine learning solution, we can provide to this platform if we have their data, right? So first let's have the understanding of the data, and then maybe we will be able to understand the maybe we will be able to formulate the problem statement. So for example, here we have the name of the car. Okay. Now what does this head function does? It will display you the first 5 rows from your data frame, from your basically data source. Then you have the year of manufacturing of that car, right? So we have got different year values. Then we have the selling price. Now obviously, since these are used cars, this selling price will be quite lower compared to their original price when they were purchased from the showroom, right? Then we have kilometer driven, right? Then we have a fuel column, what kind of fuel is there, such as diesel, petrol, etc. Then we have a seller type. Currently we only have individual, we see only individual values because these are just first 5 rows. Maybe if we investigate further, we will come to know about what are the different kind of values that are there in seller column. Then we have transmission. What is transmission? Well, whenever you drive a car, you shift the gears, right? And there are two types of gear changing options. That is basically transmission, either manual, you press the clutch and then you shift the gear, right? Or there is another type is automatic gear vehicle, where you have installed some sophisticated technologies which will automatically shift the gears for you based on the current speed of the car. Then we have owner information, such as if the car belongs to the first owner, second owner, and so on. Then we have some car related information such as mileage, engine, max power, torque, and finally number of seats. Got it? So we have understood their business. Now we have also understood their data, right? Now, based on these findings, we have to formulate a problem statement for our data science and machine learning project. So we will have to first identify what are the independent variables and which one is the dependent variable. Now, dependent variable is the one on which we do the predictions, correct? Now, since here in this, and it is quite true for most of the businesses, because the price of the car is the major thing, right? What if we develop a application for this particular company, right? That whenever a user enters all this information, right, such as kilometer driven, fuel, transmission, owner value, mileage, and etc. So your application will predict the price of the car, right? So in this way you can help this organization, this company, to build a data science based solution. Got it? So selling price will be my independent feature, dependent variable. Rest of the values, rest of the columns will be my independent features. Got it? Now we have understood the business and data, we have formulated the problem statement. Next thing is to collect the data. Well, we have already collected it in the form of CSV file. next phase is of EDA, right? So here from now we will start the EDA. Now, as I was telling you that in EDA there are various steps. So, and also various types of data are involved, and different data requires different kind of uh, treatment in EDA, right? So let me just in a 1 minute, let me tell you that there are two types of data, categorical and numerical, right? And this numerical data we understood, right? And it is further divided into discrete and continuous. So discrete means a number which can be counted, such as whole number, right? For example, number of student, number of rooms, right? Then we have a continuous numerical values, which will be in the form of which are basically fractional values, right? Such as score of the student, area of a room in square feet, right? So all these all are examples of numerical data. Now, what about categorical data? Anything which is not numerical, means any text data, basically falls under the category of categorical data. And again, we have two types of data under categorical data. One of them is ordinal, another one is nominal. In ordinal, for example, you have a variable called size of a t-shirt, right? So size of t-shirt can be small, medium, large, XL, right? So even though these values are uh, textual in nature, right? No numeric value is there, right? This is all text, but all these value have order in them, right? That's why the name ordinal. Whereas nominal data, it consists of uh, only text and they don't have any order in it, such as gender is male, female, state or country names, right? So all these are some examples of the data. Now we need this information in EDA, right? We are going to make use of these concepts in EDA because a different strategy has to be applied in EDA for different kinds of, for numeric data, for categorical data, there are different strategies. Okay. Now what we will do, we will first have a look at the columns, the variables, if they are in proper form, right? If they are in proper, they are having proper data type, right? So what I see is that, just a minute, for that what we can do is I can call a function df.info, and here it gives me the details of the information about my data, such as there are about more than 8,000 entries, 13 columns, right? The column names and their respective data type, correct? So when I did the investigation, what I found is that, okay, that this, just a moment, this year column, selling price, kilometer driven, these three are having numeric values, right? And also if you have a look at the output, you can see here they are having data type of integer, right? So everything is okay with them, right? Then we have some categorical features such as fuel, seller type, transmission, owner, etc., right? And they are having data type of object, which is basically a string in this case, right? Got it. Next thing is mileage, engine, max power, torque. See, it is numeric again, right? But these four columns, what do you see? We see numbers, right? Here also, engine size, engine power, mileage, etc. But all these numeric values are having some units associated with them. And that's why you can see here their data type is shown as object. So they are basically string values in our data set. But we don't want string values, right? We want only numeric part of it. And why? Because when you feed this data to a machine learning model, which is nothing but a mathematical model in a nature, it will do some computations on those input data, right? And all these computations will be some mathematical operations, and you can perform mathematical operations only on numbers and not on the text data, right? So we will have to get rid of this KMPL, CC, and PHP. Got it? Now I have written the code below for the same. I will just give you explanation of one and you can follow the rest of it, right? So in Python, there is a function called split, which can be applied to a string value. So for example, here I have a text variable which is having a string. My name is Nilay, and if I apply a split function on it, you can see that all words have been splitted from the given string, right? And they are stored in a list. Similar kind of splitting I can do on this mileage column. Now, what is this mileage column? You can see here, this mileage column is having a number, space, and a KMPL string or a text, right? So I will do splitting. I will apply splitting on this mileage column, and I will split this column into two columns. The first column will contain only the numeric part, and the second column will contain only KMPL, that is the unit of the mileage. Okay, PK is asking head shape, sir, how to figure out where should we use parenthesis and not. Okay, this is quite interesting question. Okay, just a moment. So PK, are you aware of the concept called object-oriented programming? Object-oriented programming. Let me see if I can explain you with some example. Okay. Okay, but maybe you're aware of. Okay, Piki, you're already aware of it. So in a class, you have some data members and you have some functions, right? So if you want to access a function through an object, right? So you put this round brackets around it, right? So this is a function, right? And then there are some data members in your class, right? So to access those data members, you just have to use the dot operator followed by the name of that data, right? Of that variable name or instance variable name, right? So in this way, you will have an idea. Since this info is a function, we put this bracket over there, and in other case, if it is a data member, you don't need to use those brackets, right? And furthermore, if you get confused that whether shape is a function or not, right? So I'm not sure if, okay, just a moment. Okay, if you are using Jupyter notebook, just take your cursor to that particular function or to that variable, right? And just press shift tab. In case of Google Colab, you don't have to press shift tab, you just have to take your cursor to that particular one. Now here, what does it says? There is a pop-up, and what does it say? That it's a property. It means it's a data member. And what about this? If I take my cursor to this info function, just a moment, info. So you can see that we have got a pop-up, and it is basically showing that it's a function, right? These are some of the parameters that you can pass it to it. Okay. If you switch to, okay, just a moment, let me new, let me open Jupyter notebooks. I think somebody's microphone is on. I request to put it on hold. Notebook. Okay. Okay, fine. Now see here. If you get confused, if read CSV is a data member or a function, right? So you just take your cursor over here and press Shift tab, right? And you can see that it will open a documentation for you. And here it is saying pd.read CSV, and there is a parenthesis, right? Along with some parameters. So you will come to know that, okay, this is basically a function, right? And if I type df.shape, right? And now if I take, so you can see that it is showing me that this is a type of property. And here it was a function, right? Because there is a signature, right, involved in it. And it's a matter of practice. Once you write once you write the code for many number of times, you will automatically remember that there is no need of those parentheses here. Okay, PK. Sorry, I'm just using your initials. Ranasinghe, okay? Ranasinghe, yeah. Okay, fine. So here what I have done is that I have splitted my mileage column into two parts, and I'm going to use this numeric value only, okay, into my existing data frame. So I have created a new column called new mileage, and you can see here, just a moment. You can see here now a new mileage column have been created, and it contains all numeric value only, right? But the original column of mileage, it was of string type, right? So we have just fetched the numeric part. So you can see here, after calling df info function, you can see that new mileage column is still having object data type. It is not int or float, right? So I will have to explicitly change its data type. So here I'm changing its data type to float. Got it? So this is quite common practice in EDA, that maybe your variable are in a different form, and maybe it is in numeric form. You may have to convert it into a categorical variable, or maybe it is in categorical variable and you will have to convert it into a numeric form, which we have done just now. Now I'm going to skip next few lines of code, because because what I'm doing here is repeating the same procedure on engine and max power, because engine and max power, as I can show you, it contains CC. So we don't want this CC and BHP value. We want only these numeric values. So same thing, what we have applied on the new mileage, same thing is being applied on the engine. We are splitting it and then creating a new engine column, right? And again, changing the data type of new engine. Same thing we are doing it for the max power, which is in measured in BHP, right? You can see that we have splitted it and now creating a new max power column. And if you just let me just show you the data. Okay, here I have actually taken transpose of the df dot head. So that's why row have become column and column have become rows. So you can see here new mileage, new engine, and new max power columns have been created, and now they are having only numeric values. And these old columns were containing numeric value as well as their units, right? So this is one of the common practice, common step which is done in EDA, right? So there were some issues with converting the data type of new max power to float. I'm not going into the detail of it because I want to cover a much important topic related to EDA, right? So please uh, let me go to the next section, right? Next thing you should you may do in your EDA is search for the duplicate values, right? uh, it is quite common thing that your data set may have duplicate values, right? And if you have duplicate values in your data set, then machine learning model will not learn anything new, any new pattern from those duplicate rows, right? So the best way is to delete those duplicate records, right? So here I have drop function is basically used to delete the rows or column, right? So I have deleted them. Next thing which is quite important in exploratory data analysis is to check for missing values or to check for null values. So here is the function df dot is null, right? So it will return you either true or false, but we don't want true or false. We want to see exact number of null values in my data frame. So after that you call a sum function on it. Maybe I'm going quite fast, so if people who don't have knowledge of Python, or maybe beginner level knowledge of Python, you might be getting confused with the amount of functions that I'm introducing, right? Here I'm using two functions on a variable, right? Sort of this is cascading effect, right? Don't bother about it. Try to understand the concept behind it, right? Because syntax is something which you can learn at any time, right? uh, and if you practice it, you will automatically come to know what code has to be written. Now try to focus on the concept. So as I was telling you, we have to find out the number of null values. Now why we should bother about null values? First of all, as I have told you earlier, that machine learning model expects data to be cleaned in numeric form, right? And if you pass any null value, right, then what will happen? Your model will throw you an error, right? That it is not able to handle those null values because it can do computations only on the numeric values, right? So that's why we have to uh, treat these null values. Okay, if you are following everything whatever I have mentioned, please let me know, or if you have any questions, please ping me in the chat box. Okay, so here what I found is that there are, I mean, out of those 8,000 rows, for these 5 columns there are about 200 rows which have some null values, right? So we have to treat them. Now there are there are multiple ways, multiple options to handle such kind of null values. First and the easiest option is to delete these 200 rows which contains the information related, which contains null information, right? But uh, there are some other scientific ways to fill those null values, right? and one of them is to fill them with mean value. Now why use mean value? So you can see here I have written the code df new engine fill na, okay, with df new engine dot mean. What is df new engine dot mean? So this new engine contains basically engine volume, right? Or maybe, okay, I have not calculated it. Okay, just a minute. Okay, let's consider the example of new mileage dot mean. So what this code will give me, it will return me the average or the mean value for this column new mileage, which comes out to be 19.5, right? So, and here I have written the code that wherever you find null values in new mileage column, replace them, fill NA, replace them with mean of the new mileage column, which is 19.5 in this case, right? And now the question arises, why we use this mean value? Why not other value, right? Okay, just a moment. Okay, now according to statistical findings, all the natural phenomena. Okay, Vanudhya is saying deleting the whole row or just a cell path. Well, deleting whole row. Okay, uh, because if you just delete that cell path, I mean that doesn't make any sense. Again, if you delete that information, I mean it is going to have a null value in that case, right? Null value means no value, not even zero. Okay, the value was not entered for that particular cell. That is the meaning of null value. Now most of the natural phenomena, they follow this normal distribution, right? Now what is this normal distribution? You can see that if you I mean let's take the example of height of uh, people around the world, right? And if you try to plot those heights in terms of this probability density, you will find that majority of the data, okay, majority of the people will have height in between 5 to 6 feet, right? So 5 to 6 feet will be located here, and maybe 3 feet, maybe 6 feet to 7 feet people uh, are located in this range, okay? And here we have short people, maybe because of, unfortunately, due to some genetical disorder, right? So they may have so these are very few people, right? As you can see that there the count of these people is very low, right? So you can see that people with short height or people with extreme higher height, right, maybe above 7 feet, right? So but we have got very low number of them, right? Now you can see that most of this height data is concentrated around this mean value of the height. This mu represents this middle point represents the mean, right? So we are applying same thing to our in mileage, right? So instead of filling null values of mileage with some random value, if we took a decision to fill with them mean, right? So in that case, since most of the values of average will be concentrated around the mean, no doubt they will not be exactly the same, but you will have but that error will be minimum, right? So that is the reason that this mean value is used to replace the null values. Got it? Another approach would be you check that which rows have the null values, right? Get the details of those cars, and you may ask the domain expert, because in data science project you also have a domain expert, right? So you may ask a domain expert that this is the car for which I'm having null values for mileage. Can you please get me the mileage value of that car? And you may manually change it, right? So that is another approach, but it is quite lengthy and usually takes more time, right? So again, depending upon the scenario, the time, the type of problem, you will have to choose one of the option. I hope you can see it here clearly that after replacing those values, all of the null values have been removed except for the torque, right? Now when I now why now let's have a look at the torque, just a moment. Now torque is shown in this form, Newton meter at the rate RPM. Now again, this is a text and it has got, I mean, numeric values there and also text is there. So these are some units. So what I can do, again, I can do the splitting and I will just create a new column called Newton meter where I will save this 190 value, right? And another column which is of RPM, revolutions per minute, and I will just save this value, right? But that is quite not possible, because when I further studied about, further investigate for this torque value, I see that in some cases it is the range for the RPM is given and not just the exact RPM value. In some cases this kgm unit is mentioned, right? So it is quite complex uh, to get rid of these units. And also when I searched about what exactly is torque, I came to know that basically this power bhp is calculated based on the torque value. So in a way we have preserved torque value in our engine power, right? So because of these two reasons, first is that it is quite, I mean, it's not that you cannot do it. I mean, there is, again, you will have to write some complex code, and maybe you finally you will be able to fetch these values, right? And another uh, thing is that this max power is calculated based on torque. So in a way, the torque value is preserved in this max power. So considering this fact, I've taken decision to get rid of this torque, right? So in EDA, it's a quite common practice that you create some new columns, as we have done here, new mileage, new power, etc., right? And we delete some old columns, right, such as the mileage column, engine power column. We have deleted them because we have got uh, a new feature, new value out of them, right? Next point I want to tell you is about feature engineering. Now, what is feature engineering? In feature engineering, we create a new column from the existing column. How? Let me show you. For example, here in my data set, I have a column called year, which is nothing but the manufacturing year of the car, right? But it seems that it is, I mean, it is an integer value, right? It's a numeric value, but it is basically year value, right? It's a date time value, right? So it will not help us uh, to find the selling price, right? Instead of that, if we create a new column called car age using this year value, that will be much more beneficial. So same thing I have done here. I'm creating a column called car age, right? And I have written some code here. Again, I'm not explaining it because we have so many other concepts to cover, right? Maybe if you just have a look at the code, you will come to know that here I'm calculating the current year, right? And then I'm subtracting current year from the year column, and that will give me the car age. And you can see here car age column have been created, and it is having the value of the calculated value of age. Got it? So this is called as feature engineering. We have created a new feature, new column, new variable from our existing data. Now we don't need this column anymore, right? So I'm deleting this year column. Okay, so all this what we have done up till now is basically a part of data cleaning. We were trying to get rid of null values, creating new features, converting data into appropriate data type, right? Now we reach the most important part of exploratory data analysis, which is called as univariate analysis, bivariate analysis. Before that, if you have got any questions, please feel free to ask me. I hope that you are following everything, whatever I have mentioned. These are, I mean, again, as I mentioned, forget about the code as of now. If you are not well versed in Python, or if you don't know what is pandas and all that, try to try to understand the concept in EDAs, right? Okay, fine. So what is univariate and what is bivariate analysis? As the name suggests, univariate means one. So we do the analysis of each individual variable in our data set. We look at its distribution, right? And in bivariate analysis, we study the relationship between two variables, two features or two columns, right? And to do so, we have got different kinds of graphical and non-graphical methods, right? So let me start with a univariate analysis. So as far as the categorical features, okay, so what PPT I had explained, the topic categorical features and numerical features, I hope you remember them, right? So a different approach is used for categorical and numerical features as far as univariate and bivariate analysis is concerned. So what are they? So in case of categorical features, let's take the example of fuel. What are the different types of values of fuel? Diesel, petrol, LPG, and CNG, right? So these are some gas-based fuels, right? So whenever you have such kind of categorical feature, that is fuel, we may use a count plot, and this count plot function is available in Seaborn library, which is a data visualization library in Python, right? So you just write sns dot count plot and x equals to, because you want fuel to be on x-axis, right? And it will give you this kind of bar chart. So unique values of fuel are mentioned here, and their respective counts are on the y-axis. So you can see that in this particular country, the majority of the vehicles use diesel and petrol, right? And very few vehicles are using LPG and CNG gases. Got it? So this is how you get an idea about the distribution of data for your particular column. Okay. Am I saying can we do those things via RStudio? Yes. See, Python programming, R programming, Swift, Julia, these all are basically tools to do this kind of analysis, right? If you are comfortable with some other languages, you can do it using R in RStudio, right? Not an issue. But if you are serious about data science and machine learning, I would suggest you to go for the Python. The reason is that I mean, as far as the industry standards are concerned, many of the jobs are basically asking for Python, right? R is used, no doubt, But I mean, if you Google it, you will see that clearly Python is dominating as far as this data science and ML world is concerned, right? Okay. So again, there are few more technical things. Now, since this CNG, LPG constitute own merely 1% of your whole data as far as fuel is concerned. Now, this is the graphical analysis, univariate analysis. You may use this fuel df fuel dot value counts function. So that will give you unique values of fuel along with their number of occurrences in your data set. So as you can see that these gaseous fuels have less than 1% of contribution in our data set, right? So maybe in such cases you may club them under one values, which is gaseous fuels, right? So again, here some other uh, categorical features. So you basically do data analysis in a way, right? So you are exploring through this data analysis that what kind of data distribution is there. In case of transmission, majority of the car are having manual transmission, right? Most of the cars are from the first owners, right? First and second owner. Now, as far as so that was about univariate analysis of categorical features. As far as this, just a moment. As far as these numerical values are concerned, for example, car age, okay, we use something called as histogram, right? And this histogram gives you an idea about the presence of outliers or skewness in your that particular column. And now there are different scientific ways to remove to reduce the skewness or to get rid of those outliers from your data. I'm not discussing about that part because as we have a limited time, so you can have a look at into it. So we use count plot for categorical features, and for numerical features we use histograms to do univariate analysis. Next comes bivariate analysis. In bivariate analysis, what we do is that we study the relationship between two variables. So there is a function called df.core that stands for correlation, right? And it will return you one matrix which I have saved in a variable called core mat. And if you print it, you will get output something like this. And if you want to visualize it to improve the readability, you may plot a heat map and pass that correlation matrix to it, and now you have a nice visual representation of correlation values. So using this particular heat map, you can see that how variables are related to each other. Let me just in a 1 minute, I'm going to explain. I'm not going into the again deep details. I will just highlight one particular thing. For example, here along this first row, I have a selling price, right? Selling price. And along the rows, I have other values such as kilometer driven, seats, mileage, etc., carriage, etc., right? So for the first cell, I have value equals to 1. Correlation value for this first cell of selling price is 1. Why? Because if you look at the column here, it is selling price. So these are one and the same thing. So hence the value correlation value is 1. This correlation value ranges from plus minus, it can be between -1 and +1. If it is more towards 1, it means that those two variables are highly correlated. If it is more towards -1, it means that they are negatively correlated. Positively correlated means with increase in one value, value of one feature, the value of another feature is also increasing. So that's why, since these are same column, same values, that's why the 1. Now, interesting fact here is that selling price is having 0.44 correlation value for new engine size. Okay, so that is quite correct, right? Because as the engine size increases, right, for small cars they have small engines, for bigger cars they have bigger engine, and obviously bigger car cost a lot, right? So you can see that selling price will increase with the increase in the engine volume or engine size. So that is why the correlation value is 0.44. Where about whereas in case of car age, selling price is having correlation value of minus 0.43. Why minus value? Because as the car age increases, the selling price will go down, right? So with the help of this nice visualization, you will get an idea that which factors affect the selling price, and accordingly you may neglect uh, some columns which have very low correlation with your selling price, right? So that was all about bivariate analysis for numerical variables. Now for categorical variables, we use something called as box plot. Let me show you what is box plot. Yeah. So here on the y-axis we have selling price, on the x-axis we have transmission, and now you can see that the for the car which have automatic transmission, their corresponding seller price is quite it is on higher side, right? It means that transmission variable value of transmission variable affects the selling price. That is quite obvious, right? So these are some of the analysis which I have done. Okay, and now I'm just skipping the part where I have calculated and removed the outliers, and I would like to jump to the last topic of our EDA. So we have seen, I mean, there were some columns, numerical columns. We have got rid of their units and we have just taken their numeric values. But what about the variables such as fuel? Because fuel is having diesel, petrol, something like that, right? Now, how to convert them into a numeric value? Because machine learning understands only numeric values, right? So, what to do? We use something called as uh, one hot encoding. We encode them into numerical values. How? For example, the first for this we are using this get dummies function, and you can see here the fuel column is now converted into three different columns. Okay, maybe I will do it like this. Just a moment. Good. So we have got four different values for unique for this fuel. I will finish this webinar in just 2 minutes. For the Cormet, transmission fuel is not included. A very good question, Vanodya. This is a good observation. See, because transmission fuel, these are categorical in nature, right? These are not numeric values. Transmission can be either automatic or manual. Fuel can be petrol or diesel, right? So you can calculate correlation formula. You can calculate correlation using this formula, and obviously this xy need to, I mean, this is correlation between variable x and y, right? So both the variables needed to be in numeric form, then only you can calculate correlation. That's why you might have seen that there is no categorical feature available here, right? There are about 13 columns, more than 13 columns maybe, but only those which are numeric in nature, they are involved in this particular uh, correlation matrix, right? Nice observation, by the way. So for the fuel, what to do? Well, we apply one hot encoding So our fuel column will now get converted into 4 different columns based on their unique values. The first car is having diesel fuel. So you can see that the diesel is having 1 value for the first row, remaining column size is having 0. There is a car which have a petrol fuel. So that row will contain petrol column value equals to 1, rest of the columns will have 0, right? So in this way, this is how it works. Okay, there are many other additional things. There are few more techniques which are left, but because of the time constraint, I would like to stop here. If you have any questions, please let me know.
Thank you very much, sir, for the interesting and informative discussion along with the practical session. So now it's
Thank
time
you.
for the participants to clear their doubts if they have any. So feel free to ask any questions by simply unmuting yourself, or you can type them in the chat box below.
And one more thing I would like to let you know, that being a data scientist, you will spend most of the time in this EDA, doing EDA. And don't get overwhelmed with so much code which I have written. It's a matter of practice. If you learn Pandas, Python, and you practice a lot, you will automatically get hands on it. One small request, Sandalu, I would like to share a link of one Google form just to collect the feedback from the participants. Is it okay if I
It's
share
okay,
it
sir.
here?
Yeah, okay, sir.
Okay, thank you. Please check your chat window, and if you have any questions, please let me know, and meanwhile you can also submit the form, right? So I have just given some ratings, some questions and some ratings. So 1 is for the poor performance and 5 is for the good performance, or the best, right? So please go through that Google form, because your feedback is quite valuable to me, right? And I do conduct such kind of community sessions you will be notified accordingly. And if you have any questions, please feel free to ask me questions.
If there are no questions for the participants to ask, I would like to invite Mr. Tushar Ranasinghe, the Vice President of the Electrical and Electronic Engineering Society of University of Peradeniya, to deliver the vote of thanks. Before that, if you have any questions, please ask and raise your hand and you can ask now. Over to you, Tushar.
Thank you, Soumya. It was a great session we had today. We learned a huge deal on exploratory data analysis through this session. I would like to thank everyone who helped to make this session a success, especially Dr. Nilay Karade for delivering this wonderful session. Thank you very much, sir. And Dr. Roshan Indi Godley at the Senior Treasurer of Electrical and Electronic Engineering Society for arranging this session, and all the committee members of the Electrical and Electronic Engineering Society, and finally all those who turned up here for this session. Thank you, everyone. Thank you.
So this marks the end of another interesting session of the talk series. So we are most grateful for you for making time and sharing your knowledge with us. And thanks to all the participants for actively participating throughout the session. Thank you.
It's my pleasure. Again, Oyata Stuti from my bottom of my hearts. Okay, it was nice to have such a gathering and wonderful audience. I can see that they have asked different kind of questions, and and they were noting each and everything, right? So I also enjoyed it. Okay, so
Thank you, sir. Looking
thank you
forward
very
for
much.
many other programs with you.
Sure. Thank you.
Thank you.